Hi folks, this is the fourth tutorial that I'm doing in this present series, which is doing some frame structures in the 3D Experiences FEA solver, which is the ABAQUS program. Now, the example that I do here is coming from the reference below, the YouTube reference below. And this YouTuber has done this problem in its entirety in the ABAQUS CAE program. So I'm going to replicate the steps to see how it works in the 3D platforms, 3D Experiences platform. Now, it is a two-bay frame structure, and we're going to treat the roof as a rigid structure. So, and keep in mind that tutorial one dealt with creating this model in a sketch and then join it so that when I meshed it, there were no issues at the interface. Okay. Tutorial 2 dealt with the case that I did not join this thing. However, when it came to meshing, I actually checked a box which said that if there are two nodes within a certain tolerance of each other to be merged. That's why, although I didn't join it, there are different nodes at the two sides of, for example, these juncture points. But because I checked that box, they're merged together and there were no issues. Tutorial 3, I did not check that box, so there are different nodes right at the junctures. However, I tied them with a tie connection feature. This is a similar type of problem, but I'm going to tie the nodes associated with these three juncture points so that they move together. Okay. Here is the geometry. These are roughly the properties of concrete, and although the density of the concrete is here, we're going to reduce it by a factor of 10,000 because we replace essentially the mass of this roof, these two top horizontal beam with the lumped mass, which is based on the dimensions that are given and this density. And we don't want these vertical columns to be contributing to the natural frequencies of the structure. Therefore, we're going to reduce the density by a factor of 10,000. Now, the YouTube reference uses the two-dimensional elements, B22. These are quadratic elements in 2D. Now, we don't have 2D elements in 3D experience, so I'm going to be using three-dimensional beam elements, but with a linear variation. But to make it two-dimensional, in effect, I prevent the motion of the frame in the transverse direction. That automatically reduces anything that we do in 3D element to 2D element. Okay, and these are the frequencies that are obtained by the YouTube reference, and this is what we should be getting hopefully. And we're going to you can see that it's going to be a very good match. We'll do that in a minute. Now, the one thing that I want to point out to you when I create these rigid elements, the support one, which is for creating rigid element, is going to be these two top horizontal pieces, and the reference point is going to be that location. So basically, we place the mass of 500 kilogram at this reference point, which is support 2. And also, when we create the tying for the main pieces, we're going to use these top two horizontal uh, lines, and for the secondary structure, we're going to use these three vertical columns. Okay, so that's what we're going to do. All right, let's move on. All right, here's the 3D Experiences interface. So we're going to start with the part file. There we are. And I'm going to create five points and then the lines in between them. So the 5 points based on the dimensions that are given, one is at 0, 0, 0. Another one is going to be 6100 millimeter up. I'm sorry, not 61. Let me see for a second. 3650 up. Okay. All right, let's move back a little bit so we can see what's going on. Here's a view. This is the fit. There we are. And then we're going to create a point to the right of this, which is y coordinate 6100. And then another one to the left of it, minus 600, 6100. There you can see that. And then we're going to go down. So that's going to go to 0. That's this point down here. And then with the plus, also 0, which is going to be this location. Now, because the cross section is non-circular, I'm going to create a orientation point here, which I will make it to be, for visual purposes, 1000, 0. So right there, and then cancel. So basically, we have six points: 1, 2, 3, 4, 5, 6, 7 points. The seventh one is the orientation point. Okay, so now we're going to create our lines. So this is one of the vertical columns. Then another one from here to here. This is going to be the first horizontal roof, horizontal beam from here to, well, let's go here. We cancel that. What have we got? Let's try it again. From here to here. Okay, and then from here to here. And finally vertically down. This is the column on the right. And we're done. Okay. Now these points that we created, we can hide them except for this last one that we're going to need at some point. I'll leave it there. But the rest of them I'm going to hide because I don't want inadvertently put restraints or boundary conditions on these points or put loads on them. We don't have any loads, but you can't put it on points. Okay, so let's go ahead and apply material properties. So we go to tools. Here is our create material. Today is February 6, 2024. And I'll call it a two-bay frame. I don't know whether it takes comma or not, but I'm not sure. Maybe it does, I'm not sure. Yeah, I guess it does. All right, so it just created the material, right click, apply, and then we close this window, apply it to that part, and use the green check mark to be able to input the values. So let's go here, double click. So it's the structural general option. Density is that reduced dummy density 0.24. Okay. And then we go to ABAQUS multiphysics, mechanical, elasticity, elastic, and 30 GPa. And the Poisson ratio is 0.3. As Poisson ratio is not used for beam problem, actually, I can't remember, what was it? 0.2. 0.2. And then we say, okay. Good. So as far as the model is concerned, this is all done. Now we're going to go to the measure, which is structural model creation, MTFEM. And we're going to mesh this with element size of 200 millimeter. We do it one by one, and with beam measure, and mesh it, and then say okay. Another one. Once again, you can see same right here. I didn't realize that there was a quadratic element there. I honestly, this is the first time I'm seeing this thing, but anyway, I must have missed it before. So I'll still use linear one. It looks like it also has the quadratic elements right there. But anyway, these are three-dimensional to begin with. So we say a mesh, okay. And then another one, this vertical one, mesh, okay. Mesh, Okay. And the last one is over here. Now, because of the way I'm doing this thing, there's going to be duplicate nodes on the sides of, well, what I mean by duplicate node means different nodes of different node numbering at this juncture to the left and below it. Okay. Uh, and in the event that you want to confirm that, so what you do is you go to under, uh, let me see, first of all, let's update the mesh, and then you click on visualization numbering. That's okay. So we go to this display, numbering visualization. Okay, it says update it. We're gonna update it again. And now you click on this. And if you hide the part so that you can see the nodes, so let me hide the part. And if you're getting close here, from left side and from right side, you're going to see different node numbers. Now, hard to see here, so let me change the background color. So I'm going to change this thing, the ambience, to the dark blue design. Now you can see when you go this way, you see 20. When you go down below, you see 2. That's why we have to use the tie feature in order to make sure that these nodes move together. Okay, good. Now let's go ahead and do the rest of the problem. So on the properties, first we define the 3 different cross-sectional properties. So here's the profile of the beam. First one I'm going to call the vertical or side columns. Side columns. And it's going to be rectangular. And if I'm not mistaken, the size of those is 150 by 150. So 150 by 150. Okay. Do another one. Middle column. Middle column. All right. And it's going to be once again rectangular. And the size of it is going to be 250 by 250. 250. These are just the shape, just profiles. Later on, we have to create a section. And finally, we do the horizontal beam. I'll call this thing horizontal beam. Again, rectangular. And the size is 200 by 200. Please note that in order to mesh that with beam elements, you have to give it properties, although these numbers are not used because we're going to replace it as a rigid element and then the lumped mass. But still, to mesh it, you need to have defined properties. Okay, good. Now we're going to define the beam section. So this guy, let me actually do the following. Cancel that. You can put it on beam, or you can put it on element, or you can put it on the model itself. So show the model. There we are. And now you click on beam section, and this fellow and that fellow. These have the profiles which are side columns, and the orientation is that point. They all have the same orientation. So another one. This is the middle section, so choose the right profile, and for orientation select this. All right, finally these two, this one and that one, they have the horizontal beam, and orientation once again is the same thing. All right. Now, incidentally, in the event that you want to see the cross section, first let me update this. So you go to display, under display preferences for beam rendering, you can use solid. There we are. Okay, but I'll keep it back, put it back to nothing. Okay, good. Now, While we're here, we're going to declare these as rigid members. So we go here to connection. Here is the rigid connection. For the rigid connection, you select that guy and that guy, these two edges, and basically what I'm showing you is these two edges are selected. And for the support, I don't want the ground. I want that middle point. So see that vertex? I'm going to put this is going to be the reference point associated with these rigid elements. And that's where we're going to place our lumped mass. We say, okay. So we do have a rigid connection here. Here in the tree, you can see that right there. And then we're going to go to abstraction under a lumped point inertia or lumped mass. You select that same vertex and you put 500 kilograms on it. Okay, good. Let's save this. All right. Now we're going to go and basically do our finite element solver structural scenario creation. Okay, good. Choose the finite element model that you created. It's a structural problem, obviously. And for the procedure, see, for the procedure, there's an exclamation mark here that you have to select what is it that you want to do. Well, I want to do a frequency analysis, modal analysis. We'll extract 10 modes, that's fine. And now we're going to do the boundary conditions. First of all, if you're going to make this, these are just two-dimensional element. Since they're not two-dimensional element, all we have to do is to say, don't move in the x direction. So what we're going to do is under boundary condition, I select all of these edges, and I say, do not move in the direction x. Do not move in the direction x. Now, these rotation about y and z are also 0. However, it really doesn't matter. Just leave it like this. Doesn't do anything. Now, this middle one, this point in the middle is actually a clamp. So you just go and apply a clamp boundary condition here, or you can say no displacement in x. Already we know that. I can take that off because already it doesn't move, but why not? Okay. So this is repeated twice. One is for the vertical line, but it doesn't matter. I can take it off. It makes no difference. Let me take it off. Because already we know that it doesn't move in direction A. That's a clamp condition. And these two are pin conditions. So click on that. So these things, already we know that it doesn't move in direction X, but they're pins Y and Z. And that is all we need to do. If it's two-dimensional, then we can check these, although it really doesn't do you any good or doesn't do you any harm. But it can rotate about the x-axis, right? It can rotate about the x-axis. It cannot go in the x direction because we already fixed these lines. All right, and save it and run it. Okay, so we go to simulate. First of all, do a quick model and scenario check. Ooh, what is the problem? Fixed displacement 3 does not have correct number of supports. Okay, let me see for a second. Displacement 3 is right here. What did I pick? Oh, I didn't even select it right there. I didn't even select it. So it's that point right there. Now it's okay. All right. So now you can see why it's a good idea to do a quick model and scenario check. That's good. Let me save this thing. And then we do a simulation check. There are some warning messages. It's a good idea to read these warning messages, but I have a bad habit. I don't do that unless things go crazy. And then we're going to simulate it and then run it, basically. Okay. That's going to be quick. And 10 modes are going to be extracted, but there's only 6 of them that we have to, we can compare it with. By the way, that YouTuber, that professor also compares it with analytical solution, which is coming from Mario Paz's structural dynamics book. So we have a problem here. Factorization in row failed. Check the model. The analysis counter stopped unexpectedly. Okay. So let me see. Is model? Okay. So let's go ahead and do some checking here. Uh, let's check our connections, engineering connections. The tie. We have to. We don't have the tie here. Oh my God! I forgot to do the tie. Look, I completely forgot to do this step. All right, happens. So go back to the model. Yeah. Now you can see what happened because it doesn't duplicate nodes here. It doesn't know what to do. So we go to tie. Where is the tie connection? And here is the tie. See that? See that tie? And what I said is for the green one or the main members, select this and that. And for the purple one, which are the secondary one, you select these 3. And that's the step that I completely forgot. And make sure that these are checked. We say okay. And now we go back to scenario and run it. Simulate. I don't have to check the first 2, in other words, the model, the scenario check and simulation check. I just run it. Bad idea, but we'll see. I'm sure it's going to work this time. There, it's coming out. It's a good idea to learn from my mistakes, so you don't do that. All right, so we have some stuff here, but these numbers are not actually, let me go back here, are not actually close to these. So I must have missed something. Let's go ahead and see what the issue is. Yeah, these are not what I would like to have. So let's go and check a few things. Let's actually check the mass, make sure that the mass is okay. Where is the lumped mass? Under abstraction, double click, 500 kilogram, no problem, it's right there. Okay, let's check out material properties, make sure I didn't make a mistake there. Under part body, material is over here, double click, material. Actually, that's what I want. The density is that dummy density. The elasticity is 30 gigapascal. That's fine. Okay, everything looks okay here. So what I'm going to do is I'm going to go to that boundary conditions here. So let's go back to scenario right here. Let's go to that restraints. Let's go check that. This is preventing motion in the X direction. And let me also prevent the motion about Y and Z. Okay. I didn't expect it to be that have that much of a dramatic effect, but anyway, we'll see that. So this is uh, strictly two-dimensional. Okay, that's good. Let's go here. this is the, oh, this is the pin in the middle. Oh yeah, okay. It cannot move in the direction X because of what we already put in there. But just to be, it doesn't move in direction X, so I'll just check that anyways. And that other, oh, you know what? Look at where I put these things. I didn't want to put it on those. I want to put it at these at these ends. Double click. No, not on that vertex. I wanted to put it at these vertices. Let me get rid of these, remove all. This fellow. Oh, that fellow. Oh no, I'm sorry. These were because I prevented them from motion in the X direction. It's okay. These two I forgot to do. Right there. Two vertices. I forgot these. Terrible. Okay. Update and run. Terrible. I was kind of a sloppy job. I better get those numbers. And I do. Right there. You see this? 11.33 to 11, 11.33 to 11, 28, etc. 2800, 2800. So that's good. So my mistake, I did a lot of mistakes. One of them, first of all, let me show you the displacement here. All right. And in case you want to see that in 3D, in case you want to see it in 3D, so you can go to under display mode and click on this. Click on these contours. Just click on this. This opens up. Select the last tab and say, show me the profile. There. Now, I made several mistakes. I forgot to tie these. That was number one. Then I forgot to put the restraint at these ends. Okay. So I had to go and fix it, and eventually we got it to work. Oh, sorry.